Download this code from codegive.com, link in the description below. AWS S3 Bucket Permissions Access Denied, a deep dive and troubleshooting guide. Encountering access denied errors when working with AWS S3 buckets is a common and often frustrating experience. This error can arise from various permission-related issues, making it crucial to understand the different access control mechanisms available and how they interact. This tutorial will delve into the intricacies of S3 permissions, provide a systematic approach to troubleshooting access denied errors, and offer code examples demonstrating how to configure permissions effectively. Understanding S3 access control mechanisms. AWS S3 provides several mechanisms to control access to your buckets and objects. 1. IAM, Identity and Access Management. IAM users represents individual people or applications that interact with AWS. Each user has credentials, access keys, passwords. IAM groups a collection of IAM users. Simplifies permissions management by assigning policies to groups instead of individual users. IAM roles an identity that you can assume. Used to grant temporary access to AWS services or users from other AWS accounts. Roles are often used by EC2 instances, Lambda functions, and other AWS services to access S3. IAM policies JSON documents that define permissions. Policies specify what actions, example S3 get object, S3 put object, are allowed or denied on specific resources, example ARN AWS S3 mybucket / ARN AWS S3 mybucket / myobject.txt. IAM is the primary method for managing access to S3. It governs who can access the bucket and what they can do. IAM policies are attached to IAM users, groups, and roles. 2. Bucket policies *. JSON documents attached directly to an S3 bucket. Define access control rules that apply to everyone interacting with the bucket, including IAM users, IAM roles, and even anonymous users, although generally discouraged. Bucket policies can override IAM policies if they are more restrictive. Explicit deny always takes precedence. Can grant access to other AWS accounts. Bucket policies are especially useful for granting cross-account access or making specific objects publicly accessible. 3. Access Control Lists, ACLS. Legacy mechanism for controlling access. Permissions are assigned to individual objects or buckets. ACLS are simpler than IAM and bucket policies but less granular and scalable. ACLS grant predefined permissions, example full_control, read, write, to specific AWS accounts or predefined Amazon S3 groups, example authenticated users, log delivery group, everyone. Object ownership by default, the AWS account that uploads an object owns it. Even if the bucket policy grants another account write access, they do not automatically own the object. Object ownership can impact access, requiring explicit granting of permissions to the object owner. 4. S3 Object Ownership Settings *. Bucket owner enforced * all objects in the bucket are owned by the bucket owner. ACLS are disabled. This is the recommended setting and simplifies permission management. Bucket owner preferred * new objects uploaded can have ACLS set during upload. If no ACL is specified, the object will be owned by the bucket owner. Object writer * the object uploader owns the object, and the bucket owner can't control access through the bucket policy. This setting is generally discouraged. Impact object ownership determines who has control over the object's permissions. If an object is owned by a different account than the bucket owner, the bucket policy might not be sufficient to grant access. You may need to explicitly grant permissions to the object owner using ACLS, if enabled, or ensure bucket owner enforced is enabled. 2. Common causes of access denied errors. Before diving into troubleshooting, it's essential to understand the common reasons behind access denied errors. 1. Insufficient IAM permissions *. The IAM user or role lacks the necessary S3 * permissions, example S3 get object, S3 put object, S3 list bucket, for the target bucket or object. 2. Conflicting bucket policy *. The bucket policy denies access to the IAM user or role, either explicitly or implicitly. Explicit denials always override grants. Check for negative conditions in your bucket policy. 3. Missing or incorrect bucket policy *. The bucket policy doesn't explicitly grant access to the IAM user or role for the desired action. By default, a bucket is private, and access must be explicitly allowed. 4. Incorrect S3 object ownership *. The AWS account attempting to access the object does not own the object. This is particularly relevant if the object was uploaded by a different AWS account or if the bucket ownership setting is not bucket owner enforced. 5. Encryption issues *. If the object is encrypted with KMS, Key Management Service, the IAM user or role must have the KMS decrypt permission for the KMS key used to encrypt the object. 6. VPC endpoint policies *. If you're accessing S3 from within a VPC and using VPC endpoints, the endpoint policy might be restricting access. 7. Incorrectly configured AWS CLI or SDK *. Ensure your AWS CLI or SDK is configured with the correct credentials, access keys, region, etc. Double-check the configured profile. 8. Region mismatch *. Ensure you are accessing the bucket in the correct AWS region. Access denied can occur if the configured region in your SDK or CLI doesn't match the bucket's region. 9. Temporary issues *. While rare, transient network issues or AWS service outages can occasionally cause access denied errors. Retry your request after a few minutes. 3. A systematic approach to troubleshooting access denied errors. Follow these steps to diagnose and resolve S3 access denied errors. 1. Identify the user/role *. Determine which IAM user or role is being used to access the S3 bucket. If you are using the AWS CLI, use the AWS STS getCaller identity command to determine the current account and user ID. If you're accessing S3 from an EC2 instance, check the instance's IAM role. 2. Check IAM policies *. Attached policies *. Inspect the IAM policies attached to the identified IAM user or role. Look for policies that grant or deny S3 * permissions or specific S3 actions, example S3 get object, S3 put object, on the target bucket or object. Use the IAM console to review the policies associated with the user/role. Effective permissions * Use the IAM policy simulator in the AWS Management Console. This tool allows you to simulate the effect of various policies on a specific user or role for a given S3 action. 3. Examine the bucket policy *. Go to the S3 bucket in the AWS Management Console and navigate to the Permissions tab. Review the bucket policy JSON document. Look for any explicit deny statements that might be affecting the IAM user or role. Pay attention to the principal element in the bucket policy statements. This specifies which users, roles, or accounts the policy applies to. Remember that bucket policies can grant access to AWS accounts, identified by their account ID. Asterisk use the bucket policy simulator to test your policies and identify any conflicts. 4. Investigate ACLS, if applicable. Asterisk ACLS are generally discouraged unless you explicitly need them and have bucket owner preferred set as the object ownership. They can add complexity. Asterisk check the ACLS on the bucket and the specific object, if you're encountering issues with a particular object. Asterisk ensure the IAM user or role has the necessary permissions, example read, write, full_control. 5. Check object ownership asterisk. Asterisk this is a critical step if you're dealing with objects uploaded by a different AWS account. Asterisk go to the S3 bucket properties and look for the object ownership setting. Asterisk if the object ownership setting is not bucket owner enforced, the object owner will control access. Asterisk if the object is owned by a different account and ACLS are enabled, you must grant the accessing account the necessary permissions via ACLS. Asterisk recommendation asterisk set object ownership to bucket owner enforced to simplify permissions management. 6. Verify encryption asterisk. Asterisk if the object is encrypted with KMS, ensure the IAM user or role has the KMS decrypt permission for the KMS key used for encryption. Asterisk the KMS key policy must also grant the IAM user or role permission to use the key. 7. Check VPC endpoint policies, if applicable. Asterisk if you are accessing S3 from within a VPC using a VPC endpoint, review the VPC endpoint policy. Asterisk the endpoint policy might be restricting access to specific buckets or actions. 8. Review configuration and credentials asterisk. Asterisk double check that your AWS CLI or SDK is configured with the correct access keys, secret key, region, and profile. Asterisk ensure that the credentials used have the necessary permissions. Asterisk use AWS configure list to view your AWS CLI configuration. 9. Check AWS service health asterisk. Asterisk in rare cases, AWS service outages can cause temporary access denied errors. Asterisk check the AWS service health dashboard to see if there are any reported issues. 4. Code examples. Here are some code examples demonstrating how to configure S3 permissions using the AWS SDKs, Python/Bot03 and AWS CLI. A. Python, Bot03. B. AWS CLI***. V. Best practices for S3 permissions. Least privilege grant only the minimum permissions required for a user or role to perform its intended function. Avoid using wildcard S3 permissions excessively. IAM over ACLS prefer IAM policies and bucket policies over ACLS for better granularity, scalability, and manageability. Bucket owner enforced enable the bucket owner enforced object ownership setting to simplify permissions management and prevent object ownership issues. Regular audits periodically review your S3 bucket permissions to ensure they are still appropriate and secure. Use CloudTrail enable AWS CloudTrail to log all API calls to S3. This can help you audit access to your buckets and objects and identify potential security issues. Secure your KMS keys. If using KMS encryption, carefully manage your KMS key policies to restrict who can decrypt the objects. Avoid publicly writable buckets. Unless absolutely necessary, avoid making your S3 buckets publicly writable. This can lead to security vulnerabilities. Understand deny statements. Be careful when using deny statements in bucket policies, as they can unintentionally block access to legitimate users or roles. Automate permissions management. Use infrastructure as code, IAC, Tools like CloudFormation, Terraform, or AWS CDK to automate the creation and management of S3 buckets and their associated permissions. This ensures consistency and reduces the risk of human error. 6. Conclusion. Troubleshooting S3 access denied errors requires a methodical approach and a thorough understanding of the various access control mechanisms available in AWS S3. By carefully examining IAM policies, bucket policies, ACLS, object ownership settings, and encryption configurations, you can identify the root cause of the issue and implement the necessary corrective actions. Remember to follow best practices for S3 permissions to ensure the security and integrity of your data. Remember also, that security is a shared responsibility between you and AWS.